Welcome to the tutorial on matrix factorization in electrical engineering. Let us consider this electrical circuit with the input terminals and we have the output terminals. Let the input current that is flowing be equal to I1 with the input voltage V1 and the output current be I2 and the output voltage being V2. So let us try to replicate this particular circuit, electrical circuit, and see what happens in a ladder network. So we will consider the input voltage V1 with the current flowing as I1, a resistance R1, the current I2, we are measuring the voltage V2, and this is given to another circuit having the resistance R2. The voltage at this particular point is V3 and the current that is flowing here is I3. So if you look at this particular circuit, it is a combination of two different circuits. One is a series circuit which consists of the resistance R1 with input V1 and I1 and output I2 and V2. The second circuit is the shunt circuit consisting of the resistance R2. So for this ladder network which consists of the series circuit and the shunt circuit, let us try to obtain the transfer matrix. To represent the transfer matrix, we will consider the outputs and the inputs. Now for the series circuit, the outputs are V2 and I2. The transfer matrix is A1 and the inputs are V1 and I1. So this transfer matrix A1 can be represented as equal to 1 minus R1 0 1. So this is for the series circuit. If we want to represent the transfer matrix for the shunt circuit, we will have the outputs V3 and I3. The transfer matrix, let us say consider it to be A2, and we have the inputs as V2 and I2. A2 can be represented as equal to 1 0 minus 1 by R2 and 1. So if you observe, in the transfer matrix we have the diagonal elements to be equal to 1. Previously we have seen how we can obtain the transfer functions for the series circuit and for the shunt circuit. Let us combine this together and see for the ladder network how we can obtain the transfer matrix. So we have A1 to be equal to, corresponding to the series circuit, we have this as 1 minus R1 0 1. And the matrix corresponding to this shunt circuit, we have it as equal to 1 0 minus 1 by R2 1. Now if you want to find out the transfer matrix for the ladder network, you will consider or start from the output side. So this would be A2 and then A1. So let us multiply these matrices. So on multiplication we get the result as, so for the complete ladder network we obtain the transfer matrix to be equal to 1 minus R1 minus 1 by R2 1 plus R1 by R2. Now let us solve another numerical and see how to simplify further. Let us say they give us a question to design a ladder network providing us with a transfer matrix. So in this question they have asked us to design the ladder network. So let us assume that the ladder network consists of a series circuit first and then it consists of the shunt circuit. So assuming this is our circuit, so this would be the series part and this is our shunt part. And in the previous case we have seen what is the equation for the transfer matrix of the ladder network. So let us use that and tally that with the transfer matrix that they have given to us. So we had obtained A2 into A1 to be equal to 1 minus R1 minus 1 by R2, 1 plus R1 by R2. So this is equal to 1 minus 8 minus 0.5 and 5. So what we are required to do here is we need to determine the values of the resistances in the series and the shunt circuit. So comparing these two matrices, we have R1 to be equal to 8 ohms, and we have 1 plus R1 by R2 which is equal to 5, or we can also consider this part, that is 1 by R2 to be equal to 0.5, which implies R2 is equal to 2 ohms. So if you know how to write the transfer matrix for the series circuit and transfer matrix for the shunt circuit, you can easily draw a ladder network, obtain the transfer function, and if they ask you to design the ladder network, you can compare with the matrix and find out or determine the elements of the series and the shunt circuit.